Hello there. Welcome to this video where you get to learn more on how you can approach various GMAT questions in the GMAT exam. In these videos, we do select questions from various topics and we work through them together with you to show you how you can approach the questions using various strategies as you learn better approaches and also probably gain a better understanding on how you can do so. My name is Joshua Obuya, trainer and a mentor the Kenya Elite program under the GMAT training section. Welcome aboard and hope you will learn more. Thank you. In this session, I'd like to look at remainders in the problem-solving section of the GMAT exam. Remainders generally fall under number properties, and the questions do come in the form of also that may require some algebra to be involved. So it will be categorized basically under number properties, but will have aspects of algebra in it. So how would you take a look at, how would you probably approach these questions to get them correct? So we'll look at questions of different difficulty and we'll be looking at how do we best approach each question to be able to progress. So we'll dive right into see how to go about them. The first section we'll look at, the first questions we'll look at are questions of low difficulty. These are questions which many students get correct. So therefore it's felt that students don't have a challenge to getting these questions correct. But how would you approach them nonetheless? So let's take a look. If you want to mind, you can pause the video, attempt this question, then pause and we can look at it together. So we have a question that if n is a positive integer, what is the remainder when 3 raised to 4n plus 2 plus 1 is divided by 10? What is the remainder? So we have this choices 0, 1, 2, 3, or 4. So that is the question. So that how do you approach this? So you have 3 raised to power 4n plus 2 plus 1. Then you divide all this by 10. And then to have some remainder. So but before we can get to add this 4 plus 1, we need to first of all simplify this first part of it. It's 3 raised to power 4n plus 2. Simplify it to the smallest terms possible so you can be able to know the units values. When you get the units values, you add 1 and you see if at all the remainder actually is less than 10, or that is what you need to get. If the remainder is less than 10, then that will be, if the units value is less than 10, then it will be the remainder, because the divisibility of test is that test of 10 is that if the number is divisible, ends in 0, it is divisible by 10. And to get the remainder, it is the units value of any number divided by 10. So that is it. So the units value will be the remainder in this case. So what does this mean? So this is 3 raised to 4n times 3 raised to power 2 then plus 1. So this is 3 raised to power 4n can simplify it further to have 3 raised to power 2n, or just 2. Let's have 3 raised to power 2, then have 2n on the outside, all this, and multiply by 3 raised to power 2, then plus 1. So that's what you have. So 3 raised to power 2, we can simplify it and get the answer. So we can have this as 9, and then raised to power 2n, 2n times 9 plus 1. So 9 raised to power 2n, that means 9 raised to power 2, and whatever we get also raised to the power of n. That is 81 raised to power n times 9 plus 1. So from this one that you can see here, it's now a bit simpler compared to what we had earlier. So this is what we have eventually from what we initially had. So 81 raised to power n times 9 plus 1. That is what will give us what this expression is, the values. And since you're looking at the unit values of this whole expression, that means you're looking at the last values of a digit, which is also a concept number property. So if the last values of an operation, so you're seeing that we have 81, it ends in a 1. So any digit which ends in 1, 5, 6, and 0, if you raise them to any power, the units of a digit is going to be the same as the base value. So that is, so in this case, you have 1. Any 1 raised to power n will end up having 1. So therefore, they end up having 1. And the last operations of a digit actually also multiply just 1 by 9. So we have 1 there. Multiply it by 9, we'll get 9. And that will be the unit value. So whatever it is, 8, 80, or 8, the version that you do have before the unit value of 81 raised to power n, whatever you have at the end of the day, we'll have it ending in 1. That's what matters. If it is eventually what do you call it? The tens values, the tens values either 1, 2, 3, regardless of what value it is. The units value will always be 1. And you're also, if you want to get the units value for the last one, also the last operations, just multiply the units value of this digit to the units value of the other digit, and you'll get the units value of this whole expression. So 1 times 9 will give you a 9 as the units value. Then now, if you are also 1 here is a units digit, so we can add 1 to this one, and you'll get a 10. That means whatever expression you'll have will be a multiple of 10. That's what it means, a multiple of 10. So which means the remainder will be 0. So plus 10 divided by 10 will actually have a remainder of 0. So, and that is how you'll be able to find yourself getting the answer to be 0. So it looks cumbersome, but it's fairly simple, or it looks fairly simple, but it can be broken down. If you know what the concepts are, you just apply the concepts, put them directly, and you just get the answer. It is basically how you go about this. Let's look at another question of similar type, and these are now, to me, it looks a bit tricky, but it's still doable. And which are some of the approaches that can be explored to get the correct answer? Of course, it could be easy simply because of the method that people can use to get the answer. We'll take a look at them in a few seconds. So you can pause the video, then attempt this question and pause on the you see. There are between 100 and 110 cards in a collection of cards. If they are counted out 3 at a time, there are 2 left over. Which if they're counted out 4 at a time, there is 1 left over. How many cards are in the collection? So let's say this collection has X cards. It has X cards. This X is between 100 and 110. I don't know what value it is, but it's of the form, actually, we multiply it. If you count them 3 times, 3A, you'll have a remainder of 2. So you'll have to add 2 to whatever you have left. So 3A, which A can be any value that will give you between 100 and 110, or 100 and, let's say, 7, thereabout. 108, yeah, 7. So now if you add 2, you can be able to get the number of cards, which is X. This same value of X, if you actually count it in 4 times, that is now 4B, because these values are different. You'll have to add 1 to be able to get the value of X. So that's what you're looking at. So since you have actually counting it in 3 and 4, which means X also has a form from the multiple, the LCM of these two, these 3 and 4 is 12. So X also is a form of 12. So this X is still also the form of 12C. And then it will most likely have a remainder. Now, what is this remainder it will have? What is the remainder it will have? So the concept here is that if you look at each and every item independently, the remainder will have to be less than 12. So what values do we have? And since X is the same, all of them, this remainder will have to be the same for all these. It should be a common remainder, a common value, for which will yield a common remainder. So what does this mean? This means that you can have the value of X in this case can actually have the remainder of values less than 12, can end up being 2, or 5, or 8, yeah, 6 plus 2, or 11, yeah, until 12. That's less than 12. Then if actually you do go by 4, which means that the value can be 1, 5, yeah, or 9. That will be 8 because the next digit will be greater than 12. The remainder again now will be again 1, 5, 9. So this is a cycle which will repeat itself for all the values. Now, what you have is that the value X will have a common digit, which is the remainder. In this case, 5 is the digit which is the remainder. So the form number, the X, this X value of ours is 12C plus 5. That is what it is. So this is the general form of the number we're looking at, and now it has to be between 100 and 110, which is just 10 values. So which value of these, which multiple, what is this value of X which will fit this criteria? So the closest number which is less than 100 or less than 110, that also if you add 5 will still get less than 110, is 96, which is 8 times 12. So I need 96 plus 5. Or also, if you go actually above, which is also less than 110, but that will be out of the range. That will be 108, which is 12 times 9. Yeah, 108 plus 5. Will exceed, so this will be out. Will exceed 110, so this is actually out. Won't be necessary to have this. So it is 96 plus 5 is equal to 101. That is how you get your answer from this. Alternatively, also there could be other shortcuts that can be used to, if you don't. This is a logical approach to this whole question. This is a logical, more or less, the ideal approach which should be used for any question of this, and it can be applied to any question to get the answer. But other approaches used as well that can be used can be used to get the correct answer.
You are watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
Can take a look at them. Let's see. Let's just try and see which other ones can be. So another one can also be probably just trying out numbers, because you have between 100 and 110. So just testing the numbers. 101 divided by 3, what do you get as the remainder? Then 101 divided by 4, what is the remainder? And 3 divided by 3, so on and so forth. That is the other option that can be done, and can also be done in less than 2 minutes. But the best method you've seen the previous one is more or less the correct approach. Now let's go a notch higher. These are now questions of 600 to 700 level difficulties. So these questions are questions which students have a challenge getting the correct answer. The majority don't get them correct. But it is just the same concepts being applied, and also applying some logic to it, you'll be able to get the answer. So you can pause the video, attempt this one, and then you can unpause and resume and see. Or also now we can just take a look at it. When an integer k is divided by 12, the remainder is 3. Which of the following, when divided by 12, will have a remainder of 6? So 2k, 6k, 4k plus 6. So we have integer k divided by 12, remainder is 3. So we'll have 12a, let's say 12a. 12a plus 3 is equal to k. Yeah, that is what form that you have. So being asked for a number which will give us, divided by 12, we'll have a remainder of 6. So let's say 12b plus 6 will be equal to each form. These numbers here, is it 2k, 6k, or 4k plus 6? So that is the question being asked. So since you have the expression of what k is, we can just substitute this value k, the expression k, into each and each of these digits, and we see which one will give us a form that is equivalent to 12 times some digit, then we add 6, which will give us a remainder of 6. That is what we're looking at the end of it. That's what we're looking at. The remainder of 6 plus 6 is the key thing to look at. So the first digit you have 2k. So what does 2k mean? 2k is equivalent to 2 into 12a plus 3. Because let's multiply everything by 3. This will give us 12 times 2a, which is still less 24a plus, but it's still, let's say 12. So because we don't know what a is, you can give it, let's say, can call it, let's say d. Yeah, not d, let's say e. Let's say e, yes. So still have 12e plus 6. Yeah, because I'm saying I'm using e because e is a multiple of 12, and so 12 times 2, 24 is a multiple of 12. We don't know what a is, just giving a different form. So what we have here, we have a plus 6, so which is correct, which is matches what we do have. So that is, yes, we'll have a remainder of 6. That is the first one. How about 6k? From the look of this, probably because we have this one being a multiple of the other, it could be, because 6k is a multiple of 2k. That is what we see. So this also, it goes without saying that this could be also the same, but let's prove it. So you'll have 6 into 12a plus 3. What will this give us? This will give us, this is 72, which is a multiple of 12. So it will give us 12f plus 18. This is f then plus 18, because 6 times 3 is 18. This 18 also is still a multiple of 6, so you can still also simplify it further to have it. It's actually still greater than 12, rather, so 12 will also still have a remainder here. So this will be reduced to 12 into f plus 1 plus 6, f plus 1. So that is what you have, because you don't know what. So this can be also 12g plus 6. So what you have at the end of it is plus 6, just which relates to what we're talking about earlier. So because that is also now fits that number. And 4k plus 6, these are now also, let's see if these are also proves it. It also looks like it could be, because 4k could be a multiple of 2. But then again, how about this plus 6? How does this remainder part affect this whole digit? Let's see. So I do have 4 into k and 4 into 12a plus 3, then now plus 6. That is what we do have as expression. What does this reduce to? Is in house to about, let's say, this would be 12g, 12g plus 12, that is 12, then plus 6. So you have a 12, which is a multiple of 12 here. This also goes, so you have this as 12g into g plus 1. So it's a multiple of 12 plus 6. So you do have a plus 6 at the very end. So this also is multiple of it. So this also fits into what we're being asked for. So 1, 2, and 3 are all actually have a remainder of 12 over 6 if they're divided by 12. So that is how you go about it. So, and that is the answer to it. Now, let's take a look at the last question, which is, when you look at this category, which is, what do you call it? Also the 600 700 level difficulty. And you're being asked for the remainder after dividing 100. By dividing 7 raised to power 10 by 100. Because what is the remainder after division by 100 of 7 raised to power 10? So you have 7 raised to power 10 divided by 100. That is it. That's what is being asked. So what is the remainder? It looks a bit difficult, because will you go about being 7 raised to 7 times 7 times 7 times 7 10 times? Then you get what the unit digits are. Okay, the last digits are. Then from the last 2 digits, that's what will be the remainder, because if whatever you have, that will be the remainder, since it's 100. So anything less than 100 will be the remainder in this case. So how do you go about it? From the previous approach which had seen in the fairly easier question, what you need to do is to simplify this into a way that you can be able to get the unit digits. So how do you simplify the 7 raised to power 10 in a way that you can be able to get the unit digits? So you can, and in this case, we're looking at the last 2 digits of this expression, and the last 2 digits will give you the remainder, right? So that's what we're looking at. So let's see. We have 7 raised to power 10, which is equal to 7 raised to power 5 times 2. So this one actually, it's easier to write as 7 raised to power 2 times 5, or 7 raised to power 2. Then that also raised to power, all of that raised to power 5 will give us 49 raised to power 5. And then divided by 100. So now we have 49 again raised to power 5. How will this end up being? So divided by 100. So at this point in time, again, will you want to do again 49 5 times? Maybe not. And how about being able to find the last 2 digits of each and every power form, and then we just proceed? That's another option, because you can just find 49 raised to power 5. What are the last 2 digits you'll get? Then again, for that 1 raised to 49 raised to power 2, what the last 2 digits will get, then again multiply again by 49 again, the last 2 digits will get, so on and so forth. But that is still time consuming. We don't have that time in the exam. So here's where not would be to actually you tap into the knowledge that you do have to get the answers quickly. So we have 49 raised to power 5. So 49 raised to power 5, these are actually to mean that that also, if you look at the answer choices together, all of the last digits are different. We have 1, 7, 3, 9, and 0. So how about you use the last digit, because that is easier to work with. The last digit, the unit digits is easier to work with. So now looking at 9 raised to power 5, Or whatever the unit digits will be, it will actually be the answer to these ones. So 9, we have 9 raised to power 5. So for simplicity of numbers, let's say 9 squared is equal to 81 times 9 again will be 9, and then this will be 60, 72. 8 times 9 is 72, is 79. So for the simplicity of 9, it is actually ends with a 1. 1 if exponent is even. And for 9 raised to power x is 9 raised to power x. If x odd, what does it end with? Ends in a 9. Because it's not 9 cubed is actually ends in a 9. So in this case, you have actually 5. So whatever iterations we'll do, because it end up being 9 times 9 again, you have it 1, and then again 1 times 9 again, it end up being a 9. So the next digit will end up with, since actually it's an odd one, it will end up being a 9, ending up with a 9. So just look at the answer choices which has a 9 as the next digits, and that is answer choice D. And this will be the answer for this. Yeah. So that is also another way of approaching it. This is more or less the easiest way of approaching this question. So that way you'll be able to get the answer. The answer will be such as B. So from this, you can see that just from the same concept that we do how once you have the knowledge, and you just see how we can logically apply them and reason out your answers, you can get the answers. So thank you again for joining this, and until next time, bye for now.